Hello, everyone. My name is Kelly Dudley, and I'm with the New Center, and I'd like to welcome you to today's webinar entitled Ecocem, the Cost-Effective Solution to Concrete Carbon Problem. We're so glad you could join us today. Okay, a video recording and PDF of the presentation you're about to see will be uploaded to the new website, newconcrete.org, following today's webinar. Questions can be asked in the Q&A dialog box in the Zoom platform, and will be answered once the presentation is finished. Attendees are in listen-only mode. The ideas expressed in the following presentation are those of the speaker and do not necessarily reflect the views of the New Center, ACI, or its committees. As with all concrete mixtures, trial batches should be performed to verify concrete properties. Results may vary due to a variety of circumstances, including temperature and mixture components, among other things. You should consult your materials, cement, and concrete professionals for design assistance. Nothing contained herein shall be considered or construed as warranty or guarantee, either expressed or implied, including any warranty of fitness for a particular purpose. Okay, now I'd like to introduce you to our speakers today. John Reddy, Director of Concrete Technology Deployment at Ecocem and Vice President, Institute of Concrete Technology. John is third-generation concrete enthusiast, and his first exposure was at the age of 3, helping his father, who was a concrete technician. He joined Ecocem in 2004 when the environment was only beginning to become a focus for the construction industry. And over the last 20 years has seen the business evolve from a startup to become Europe's low-carbon cement technology business. John is a chartered engineer and holds degrees in computer science, civil engineering, and an MSc in advanced concrete technology. Steve Bryan is a managing director at Ecocem Americas. Steve is cross-functional cement industry expert with over 35 years of experience in cement operations, process and product technology, global trading, strategic planning, and business development. He joined Ecocem in 2009 and is responsible for Ecocem business development outside of Western Europe. Okay, please take a quick moment just to look at the agenda for today's webinar, shown on your screen. And I think we're ready to begin. Please, Steve, feel free to get started.
Great. Thank you very much, Kelly. And thanks to ACI New and all the staff there that made this possible and gave us the opportunity to have this webinar today. Just first, a brief introduction of Ecocem Materials, the company. It was established 25 years ago this year by Donald and Vivian O'Rian. And that beginning was with 2 plants, one in Ireland and one in the Netherlands, producing slag cement. Since then, we've tripled in capacity, adding a plant in northern France and in southern France. We have several terminals around North Europe. And most importantly, several years ago, we decided to reinvest in R&D and to go beyond slag. And to date, we've invested over $25 million. We employ 40 people strictly in the research and development of new concrete technologies. And we have a new innovation center coming online in Paris this summer, and in addition to the one that we currently have. But this innovation center is capable of doing an extensive array of concrete technology tests and is the center of our activity. And we also have 2 universities in France where we have embedded employees working alongside the researchers at the universities in concrete technology development. In addition to our R&D development, we've continued our business development plans, including a new plant for slag cement that's planned for the Port of Los Angeles. We expect that that plant will be commissioned in late 2027, producing strictly GGBFS. But in addition to that slag operation, we're continuing market development activity in the Americas also with our concrete technologies. And that effort's being led by Mike Donovan, who joined us last year. He's the technical director for Ecocem Americas. And he's leading the charge with our R&D efforts, both with academic and industrial partners in the USA and Canada. And he's currently working with a handful of strategic partners across the country to use local materials to formulate new ACT cements, and that we hope to demonstrate those cements at the commercial scale next year. I just want to introduce a little of our thinking behind the development of this product ACT, and all of our R&D efforts. And it starts primarily with our thoughts on decarbonizing concrete. And when you look at concrete, the main culprit, the main contributor of carbon is the clinker. And it's only 10% of the mass of concrete, but it's 90% of the embodied carbon. And our philosophy that we decided on was that using less clinker is the most effective decarbonization lever. As opposed to decarbonizing clinker, we feel that we can produce clinker or concrete with less clinker, and that's quicker and more cost effective in decarbonizing. A few of our other objectives when we were doing product development, we were looking for products that were scalable. We want a solution that's universally scalable so they can serve all the roles of concrete everywhere. So structural concrete, non-structural concrete, both, and that we could scale that technology that globally we could reduce emissions over 500 million tons of CO2 per year, which was an objective by one of our investors, Breakthrough Energy Ventures. It also needed to be rapidly deployable, as the need for decarbonization is urgent, the desire to have emissions in the industry by 2030. And of course, it has to be cost effective. That's probably one of the most important criteria for a successful product, because ready-mix concrete and concrete products are extremely competitive industry. So our solutions, we knew, had to be cost competitive, and we needed to minimize barriers to entry, which primarily to us meant being compatible with the existing industry infrastructure and their equipment, both in cement and in concrete. Along the way in our R&D, of course, we focused on universal scalability, but we did develop some other products, and we've deployed those products in the commercial market space. We have an alkali activated cement and concrete called Ultra, as well as a super sulfated cement. They're amongst the lowest carbon concretes possible in the world, and they've been used in infrastructure in Europe, delivered by Ecocem, some major infrastructure, tunnels, and Olympic Village, and corporate offices, and so forth. But our problem with those products were they weren't universally scalable. They utilize SEMs almost exclusively, and you simply don't have enough SEMs in the world, or the current known SEMs, in order to scale that up to say 500 million tons of CO2 per year. If you look at the chart below, you'll see that those two products are on the far right. You can get the somewhat of a relative perspective of their carbon content by the scale here that's based on clinker. And then on the far left, you see conventional OPC, then PLC, which is introduced in the USA this year. And then you look at typical mixed design with SEMs along with PLC. And in the middle, you have GGBFS, 40% GGBFS with PLC. So you can see then that Act 2 with natural pozzolans and Act 1 with slag offer a very significant reduction in carbon, embodied carbon, even relative to a go-to mixed design of 50-50 OPC in slag, or 40% GGBFS with 60% PLC. As I mentioned there, SEMs are certainly part of the answer, but they're not sufficient. We all know that fly ash availability is decreasing, at least fresh fly ash. There is a great effort to use harvested fly ash, which will fill some of the gap. And GBFS is diminishing as blast furnaces are retired in the US and replaced with electric arc furnaces. Although there will continue to be GBFS in the United States for quite a while. It won't be nearly enough, but there will be imports as well as additional granulation capacity installed in the US in the coming years, as the need for decarbonizing cements with these SEMs increases its importance. Meanwhile, cement producers also plan to decrease clinker content with the use of limestone fillers and natural pozzolans and calcined clays and a variety of ternary blended cements. And we all know that SEM providers will continue to bring on new SCMs, primarily industrial byproducts, but also some natural positives and so forth. And ASTM and the ACI are working hard to enable the use of those materials through changes in the standards. All in all, if you look out to 2050, which sounds like a long way away, but it's really just 25 years away, with the increased demand for concrete as well as the demand to decarbonize, we see that the use of these materials or the SCM market will grow by more than 60 million tons in the next 25 years. And that's a very conservative number. If we're able to get the clinker factor down lower, it could be 50% more than that. So that's a very significant amount. What you're talking about is something 60 to 90 million tons, which is roughly equivalent to today's current production of OPC. A little bit about the principles behind ACT, because it sounds phenomenal, the performance, and it is, but it's really based on very sound principles that I think everybody that would tune into an ACI New webinar would understand. So if you look to the left and just talk about a reference mix of OPC or PLC concrete, and you look at the three lines that I've tried to describe here, the black being concrete performance, primarily strength, the red being the amount of reactive binder or cementitious materials, and the green line representing the embodied carbon or the carbon footprint. You start with the reference mix on the left, both all parameters at 100%. And if you simply move to use of a high performance SCM like slag, you're able to maintain the same amount of cementitious. You get a major reduction in the embodied carbon, and you actually get a little bit of increase in performance, particularly in long-term strength. The next step is if you take out water, reduce the water cement ratio using water reducers, superplasticizers, you're able to significantly increase the strength from there. You didn't raise the cementitious content, and perhaps you raised the embodied carbon slightly due to the embodied carbon brought in by the superplasticizer. But then the magic is when you reduce the cementitious content to bring it, the concrete performance back to the original 100%, you're able to significantly reduce the reactive binder and the carbon footprint. The trick is to do all that and maintain workability and be cost effective. And Ecocem has done that by focusing on engineered particle size distributions of all the constituents, which actually means reducing carbon content, separate grinding of all the materials. That's the only way that you can maintain control over the particle size distribution of all the constituents, is to separately grind them, then blend them. And then at the same time, we pair those with complementary superplasticizers. Once the composition of the cement is significantly changed from a clinker basis to a variety of different SCMs and different mineral admixtures, there's a need to adapt the superplasticizer molecules in order to get the same performance cost effectively. So in the end, our ACT technology is a novel technology that can use conventional cement plant process technologies. It can produce that cement at equal electrical power consumption to OPC, the same kilowatt hours per ton, which is a very, very significant parameter. We all know that there's increasing demands on the electrical grid to across the board in both our efforts to decarbonize everything with electric vehicles and industrial process technologies, but also in adding new capacity for AI and data warehouses. Everyone needs more electrical power. So the ability to produce a low carbon cement and concrete with the same power consumption is extremely beneficial. We also do it with local SCMs. Our bread and butter has always been slag, but this technology is applicable to fly ash, it's applicable to natural pozzolans, it's applicable to calcined clay, you name it. And in addition, the mineral admixtures we use can run the gambit from ultrafine limestone to fly ash to any mineral, actually. It just needs to be non-reactive in that matrix. The primary consideration is the particle size itself. We also use conventional ready-mix concrete plant technology, same ready-mix delivery trucks, and the same concrete finishing methods. So in the end, we can meet all current construction industry requirements and meet the mechanical performance, the durability, and the workability of the material, and reduce the embodied carbon by up to 70%. So beyond the theory, we're actually using this cement at commercial scale in Europe in our operations. And I want to introduce now John Reddy, who will tell you about an extremely interesting project he did at commercial scale just outside of London a few months ago. So John, take it over.
Thanks very much, Steve. And thank you to the new centre. I'm delighted to be here and talk to you today. So I'm coming to you from Ireland, just across the pond, as we say. So this is a very interesting project that we've been working on. Always with new technology, everybody wants to be the first until somebody has to be the first. And then they want to know where it's been used before. So what we have is a demonstration of this project in Wembley. But we have been busy to get to this point. We've been scaling up our developments through the TRL levels, the technical readiness levels. So NASA used this scale to put man on the moon. So we're using it to decarbonize concrete on Earth. So a noble cause and a tried and tested methodology of working. We have been working not just in labs, not just in concrete plants, but in committees and standardization. So trying to enable the product's use within construction, we need certification. So one of the milestone achievements to date has to achieve European product certification back in October last year. And we're advancing this on many different fronts within the member states of Europe where we're operating. We have a lot of strategic partnerships developed through our network of our GGBFS business. So this gives us market contacts and good people that we can work with. One of these has been in France with Cemex, who have given us 10 different ready-mix plants regionally around France, which gives us different aggregate sources and types, which allows us to assess the robustness of our technology. So we're moving at scale from, you can see some retaining blocks there being poured from the back of a concrete wagon, which is being batched. So we're moving from the lab crete into the real crete and taking those steps forward in our development and moving up the TRL levels. One of the big enablers we found in the UK, and this is again a novel material that we're using. This is outside the scope of the current European performance criteria and regulations, is this BSI Flex 350. So the British Standards Institute have been looking at how we can get novel low carbon materials into the market. And one of the gaps has been standards and certification. So the ASTMs are a little bit different to the European standards. European standards are mostly focused on constituent-based requirements opposed to the ASTMs, which are often performance-based. So a stakeholder group within the UK came together, worked on this document over a 2 to 3 year period, and created a performance-based criteria for low carbon concrete technologies. And this is really a game changer for innovators like Ecocem in this space, that we can have now a framework document, a guidance document to allow us to assess the industry, the performance of our concrete before we move forward to talk to asset owners and clients about using our product. This is a project in London. So it's an iconic site in Wembley. You can maybe recognize the arch here. So music concerts, soccer, even NFL games played in Wembley Stadium now at this stage. So an iconic location. We have a small demonstration site, but of structural merit. Innovate UK, which is the British government, launched a competition called Decarbonizing Concrete back in January 24, with the objective to benchmark low carbon concretes based on a 50-50 mix of OPC and GGBFS. So the whole project is around reducing carbon. Our consortium were successful, one of 7 projects out of 80, I think, applicants. Project is led by John Sisk and Sons, who are a tier 1 Irish contractor who are active in Ireland, the UK, and Western Europe. We have Loughborough University and the BRE, who are the building research establishment in the UK, acting as technical validation. We have Ramball, who carried out the design for us. And our concrete supply partners were Capital Ready Mix, who are a local ready mix partner in the London market with seven different plants, and Crea Concrete, who are a precast manufacturer in Northern Ireland. And what we wanted to do with this project was really demonstrate how the material works at scale in the real life construction environment. So can we build, first of all, can we produce it? Can we deliver it? Can we build with it? What different types of things can we build with it? And then to give it the technical validation using the framework of the BSI Flex 350. So it's a very exciting project. We were on site as early as November just passed, and we have now completed a project over a couple of 2 months really in construction phase. And it is small. This is what it looks like. It's a simple 2-story frame construction, but of structural merit. So it's you know, it's got some columns, it's got some beams, it's got slabs, it's some stairs, different things. We have used ready mix concrete at 2 different grades. We've precast elements. We've used different workabilities. We've gone from some sort of like normal workable concrete all the way up to self-consolidating concrete. And we've even used post-tensioning on the first deck slab. So you can see that we're trying to really road test our technology as much as possible. So this is the first pour that we did. It's just a little short video here of concrete. So you can see very fluid concrete being pumped into place in this application. So we were looking for, in European terms, we're looking for a slump of around 200 millimeters. So maybe 8 to 9 inches or something like that. We are finishing concrete the same way. So Steve said that, you know, we can use the exact same construction methodologies that are in place. One of the big challenges around low carbon materials is the early age strength development and setting that can often be seen to delay practices. And one of the challenges we've had over time is, you know, the power floating operations. And we were very pleased that we could power float. So we were power floating within, 12 hours of placing. So this was in November, December, cold climatic conditions, and still keeping up with normal construction practices. The finishes you can see on the slab on the right picture, we have 3 different areas where we assessed 3 different finish types. So we've power floated one section, we used a brush finish on another section, and we just did a hand float on another section. And then within each of these sections, we sprayed a curing compound just to, again, assess was there any compatibility issues with normal construction techniques. And thankfully, we found none. The vertical elements were skipped into place. So again, a different type of construction methodology. We use different grades of timber ply facing on the formwork that we used, again, to assess the finishability and the Yastruck finish of the concrete. We have a picture coming up at the end where you can see it. It does look pretty good, and the color is exceptionally pale white as well. Striking was carried out the next day, probably in the 14 to 16 hour window, which was again within the expectations of the contractor for the time of year that it was and the climatic conditions, around about 3, 4, 5 centigrade. This is a time-lapse picture, so I'll let you enjoy that. Everybody likes a time-lapse. So that was just over a 2-month period. And this is the finished structure here. So this is it's actually temporary works concrete, and what they're going to do is for the next phase of development, they're going to use this as a prop to hang the architectural cladding panels that are going to be used. So it's going to sit there for hopefully a year at least. It's open to visitors. If anybody is in and around Wembley and would like to see it and touch it and poke it and test it and stamp on it, whatever you like to do, we can accommodate that. But it's been a fantastic project to be involved with. It is the first of structural merit, so we are in the business for finding the second, third, fourth, and really to make a change to the construction industry. Part of the technical evaluation is set out within the BSI Flex 350 document. So we have a lot of testing to do, and this is very welcome because we need to build up our credibility and give the evidence to support the adoption of this material. One of the as Steve said, with the carbon benefits, we've done a full LCA life cycle assessment of the 2 grades of concrete that we poured within it. And we could find a 68% reduction in one instance and a 60% reduction in the second instance. So really major carbon reductions available. The technical validation work has started, where we're a couple of months into that, and we'll report on that in due course. We're working with the stakeholder groups to publish case studies and give out all the technical information that we're finding along the way. So again, this is to give the confidence to the industry to adopt the technology. Steve, I'll hand that back to you.
All right. Yep. So where do we go from here? In Europe, we've already received the European Technical Assessment last year, which is roughly equivalent to the ASTM certification of a product for the cement itself. And we're continuing to work with the various countries in terms of its use in concrete and getting it approved for different concrete applications, country by country across Europe. We've already committed $50 million to a 300,000 ton a year facility just to produce ACT that will be constructed in the north of France in Dunkirk, with commissioning late next year. And an additional 400,000 will come on the following year, and another 400,000 the year after that in 2028. So we will have well over 1 million tons of production of ACT for Paris, Northern Europe, or Northern France within the next few years. We've also signed a co-development agreement with Titan Cement, or Teton, for low carbon products that are not using slag. And that effort is going to start in Europe, but there is an option to expand the agreement and the collaboration globally after we have success there. In the US, we've received third-party product certification that our ACT cement does meet ASTM C1157. And now we've begun work, specifically Mike Donovan, our technical director, is working with a few strategic partners across the country to localize ACT formulations at the various plants and markets across the US to prepare ourselves for commercial demonstrations next year. So that is the end. If there's any questions, we'd be happy to answer them.
Okay, thank you both, Steve and John, for a wonderful presentation. Now it's time for the Q&A. So if you have any questions, please feel free to enter any into the Q&A dialog box in this platform, and my colleague Sareka will be happy to field the questions and read them.
Thanks, Kelly. Thanks, John and Steve, for a great presentation. I think you covered a lot of very interesting information about Ecocem products. We have one question at the moment. It came when Steve was presenting, but John or Steve, one of you can answer. The question is the process compatible with new sustainable steel process?
Yeah, okay. So I'll be happy to take that question. So yes, sustainable steel processes, yes. So the ACT, what we're developed at the moment on GGBFS is Act 1. There are other acts in the pipeline, much the way there are iPhone iterations. And our R&I people are working on, the lower carbon steel alternatives, such as electric arc furnace slags and BOF slags and things like that. So as the steel industry decarbonizes, other slag types will be valorized, and we're already working on that. And again, we have some strategic partnerships with the steel industry around the development of such sources.
That's great. Thank you, John. All right, we have one more question. On the ASTM-C 1157 certification, are you classified as GU? I mean, general use.
We are classified as moderate or low heat according to the early age criteria of 1157. So part of the standard requirements, you work to a certain water binder ratio. Our technology is based around a water binder ratio, but also admixture technology inside, which often is not represented within standard test methodologies. So we are working to find the early age strength requirements for the test methods. But what we've proven in practice with the demonstrator is in concrete, where we're dealing with what people use every day rather than how they put the label on their product, we have early age strength sufficient for construction programs and demands. So we're not quite in that GP box, but we're in there. We fit it within it.
Yeah, great. Thanks, John. The next question is, what are your expansion plans in the US?
I think Steve has managed to shut himself off for the questions. Our expansion plans at the moment are for LA. We have been active within the American market for more than 10 plus years, assessing the market and trying to find geographic locations and opportunities and markets that are suitable. I think as we grow our partnerships, particularly with Titan, who have presence in America, that will ultimately allow us to enter into the market, not just from purely a manufacturing basis, but from a licensing technology basis. For us to build factories and to decarbonize the cement industry and concrete, we can't do that at a rate of pace to keep up with investments, programs or strategies. There's just too much cement and not enough time. So for us to have an impact with ACT technology, we need to find partners, we need to find willing participants and work on this together. So we can bring our technology to the marketplace to allow that to happen quickly.
Thanks, John. Yeah, I hope you'll find such partners and be able to bring to US, right? Another question related to US. Are there any plans as of now to build any additional plants in the US other than the Los Angeles one? It also, as I noticed, you mentioned also considering expanding to Canada. Has there been any progress with bringing your technology there?
Yeah, I'd say there's feasibility studies at the moment. There's nothing hardwired in the development plan, but like we are a strategic company that looks 5, 10, 20 years into the future. So we have business plans around that, but nothing that we can say for certain or announce at the moment.
Thank you. The next question is, what is the carbon savings showing from the Wembley Park demonstration?
Yes, so it was quite nice to get the validation of that work, because at the outset we said there was a 70% saving. And when the LCAs were carried out, it came in at a 71% saving. So that was a good endorsement of our declarations at the start. So yeah, we had a 71% saving in carbon in the concrete on the Wembley project.
That's a great number, John.
Thank you. We're impressed with it.
Yep. We have another question. I assume you will to get the client involved at early stage to use the technology. How will you do that?
Yeah, this is absolutely key. So we have a push and a pull strategy, really. So we have a profile now where people they know of Ecocem, they know we have a low carbon technology, and they're coming to us looking for solutions. So that's a nice position, but we didn't get there overnight. So we've been pushing low carbon cementitious technology since we started, really. So we've developed routes to talk to clients directly. Consulting engineers who are specifying have been tasked by clients to find low carbon solutions. So we have those solutions. People are coming to us, but we're also coming to other people. So we're looking for strategic breakthroughs with different people where we can have, I suppose, amplify our story. So the client in the UK is called Quintain Developments. They've been working in Wembley for about 18 years, and they're willing to use Ecocem Act in the next phase of development. So that's a strategic, I suppose, way of approaching the clients. But a lot of the big clients are looking for carbon reduction stories, and we feel we're in a very good position to offer them.
It's great to hear, John.
Steve,
One
you're
last
just on
question.
mute. Steve, you're on
Yeah.
mute there. You want to?
Yeah, I apologize. For the first time in my life, I had a power outage in a hotel in Paris, and I don't know what forces are at work, but I missed a part of that. But in the U.S., we have many developers and owners that are looking for us to do commercial demonstration projects, and the gap is the middle, and that is why we're currently working with strategic partners in the ready-mix concrete industry and material suppliers to localize the formulations. And then we'll be able to move forward with those strategic partners and actually do the demonstration projects for the developers and owners that we have lined up in specific geographies. So it's going very well so far, and we're looking forward for that opportunity.
Yeah, thanks, Steve. Next question is there an EPD?
Yes, we have an EPD. Yeah, we have an independently third-party verified EPD for our ACT binder. The global warming potential figure for that is 198 kilos of CO2 per ton of material. Steve showed this in the graph throughout the presentation. So yeah, we have an EPD. That EPD is valid, I think, for 3 years, and when we get into our industrial plant, we will be revising that again.
Yeah, and in
Thank
the
you.
U.S., of course, we can't have an actual EPD, but we are developing, and we have one already for a hypothetical production facility in Southern California, and we're working on another one. So we'll be able to discuss what we project the EPD values to be for ACT when we're getting ready to do the commercial demonstrations.
Thanks, Steve. The next question is, does producing ACT require much change to cement plant process?
So that's a great question. So by change, I assume you mean retrofitting. And in that case, yes, you need additional finished grinding capacity. And of course, you're going to use the kiln a lot less. So, but it depends plant by plant. As everyone knows, every cement plant is different. Is there one kiln, or are there 4 kilns, and size and scale and what type of raw mill technology? But there is a pathway where you do pre-grinding with your now spare raw mill capacity, pre-grinding of your fillers and mineral admixtures, and then you still have to have the additional grinding capacity at the end. And of course, because we're doing separate grinding, there will be a need for additional silo capacity to store the constituent materials before they're blended into the final cement product. But for a greenfield plant, it's going to look very similar. It's just going to require much less clinker capacity, and in the end, will be a much less expensive plant, because the construction of the very tall preheat tower and the rotary kiln and the complicated equipment there is the most costly in the plant, and that will be reduced to a third or a quarter of the scale that's currently required.
Thank you, Steve. Just one more question. Have you tried your technology with natural porcelains?
Yes is the answer, and the development work we're carrying out with Titan is based on, natural pozzolans. We're working with their team in Greece, where natural pozzolans are abundant. But the whole idea with ACT is that the SCM part is agnostic to. It doesn't have to be GGBFS. It can be fly ash. It can be calcined clay. It can be natural pozzolans. whatever is locally available within the market. And that's what makes it really, truly globally scalable. We know the limestone is there because the limestone has been used to make clinker. So if you have the limestone, you have the SCM, and the clinker is in the same place, well, then you have a truly globally scalable technology. So yeah, it's adaptable to whatever SCM is available.
Yeah,
That's
and I would
excellent.
add that natural pozzolans are a unique material, and our criteria is a high performance SCM. And I think everyone that knows the material in the industry would know that not all natural pozzolans are high performance SCMs, but fortunately, Ecocem also has technology expertise in activators and beneficiation technologies to bring many, many natural pozzolans.
Excellent. All right, we are getting more questions. Let's see. We still have a few more minutes. So, do you have a CE mark in Europe?
We don't currently have it, but we're in the methodology of getting. So the ETA that we have is the first kind of step in towards the CE mark. So that we're in train kind of to get that. So there's a move afoot within the cement committees as well for new types of cement which ACT will fit in. So that is certainly the change within the industry at the moment is moving towards that. And with our ETA, we'll have a CE mark within maybe one year.
Thank you. Next question. Are there any further trials planned for ACT?
Yes, so there is I'm working on a project. Everything is kind of NDAs at the moment, but there is going to be another significant project pop up in London within the next couple of weeks. This will be permanent works concrete, so it's going to be slightly different. So in a theatre in London, there is going to be ACT concrete, and I can't say any more than that due to the nature of the developments. But we are working in France regularly. We have a co-development with WIG Construction, WIGS, and we have a live lab where we're trialing the material with them as well, amongst lots of other pilot scale trials. So we're very, very active in this environment.
All right, thank you. And one more question. Are you able to use this technology for sprayed concrete?
We haven't done that yet, but sprayed concrete is something I'm very, very familiar with. I'm part of a development team that has developed concrete technology to allow for up to 80% GGBFS to be sprayed and to meet tunneling requirements.
Here we have structural shotcrete.
Yeah, we have structural shotcrete
with
solution
Ecocem with GGBFS, but I don't know about each of that. Sorry.
Yeah. Yeah, no, sorry, Steve, you're just breaking up a bit there. So yeah, we may have a solution at that, but at the moment we're not concentrating on that application. We're trying to get it into mass commercialization. But it is in our development plans to assess the performance in shotcreting as well.
All right. At the moment, we don't have any more questions. So John and Steve, thank you very much again, and I'll hand this back to Kelly.
Okay, thanks,
Thank you.
Sarika. Okay, thank you again, Steve and John. Please visit the new website at newconcrete.org for further information. While you're there, please check out our resources on lower carbon concrete production and placement. Our website provides access to our sustainable concrete guides, frequently asked questions, webinar recordings, including this one, and more. And please stay tuned for New's next webinar on April 24th, where New will be speaking about its validation and verification program. Again, thank you today for attending today's webinar, and we really do appreciate it. Have a good evening.
Thank you very much. And just to say, I'm going to be at ACI in Toronto and hope to bump into some people there. I can't see anybody on the screen, so just come up and say hi if you're there.
And feel free to stop by New's booth. We will be there as well.
Thank you. See you then.
Thank you very much, everyone.